was really impressed with the number of you that got this one right, because this one definitely, the whole contest was definitely a tricky one. But this one had a lot of to think about. Most of you found that A was always 4, so that was pretty straightforward. And most of you were able to see that 12 plus 8, 20 plus 8, 28 plus 8. So you knew that the next column was adding 8. So that column was always add 8. This column was always equal to 4. So then you knew that B would be 44. This is where it got a little bit tricky. This was add 16, then add 24, then add 32. So if you look, they're actually multiples of 8. So the next one would be add 40. So C will be 118. And then the next column is actually the same. Add 16, add 24, add 32. So the next one will be add 40, and you'll get 126. Put that one away. All right. So then all you need to do is to find A plus B plus C plus D is to add those. 4 plus 44 plus 118 plus 126, and you get 292. As I said, I was really impressed with the number of you that got that, because it wasn't necessarily easy to find those patterns. So good job if you were able to be thinking about that one. This one was quite tricky because we in grade 7, we're just maybe starting to look at ordered pairs, or we haven't even looked at ordered pairs, and we're just really looking at integers. In grade 8, we've looked at integers, but we haven't really reviewed much with ordered pairs. Remember, ordered pairs are just points on a coordinate grid for graphing. So we need to figure out x to the exponent of something has to equal 16. So that means we have to think in terms of our 16 here. So what are some ways we could get 16? Well, we could get 16 by doing 2 times 2 times 2 times 2, which is the same as 2 to the 4. So that means one pair is 2 comma 4, because remember it says x to the y is x comma y. So then think again, how else could we get 16? We could get it with 4 times 4, which is the same as 4 squared. So another pair is the pair 4, 2. Another way to get 16 is just the number 16, or 16 to the exponent of 1. Now, to be honest, grade 7's actually, we did some work with this in the exponent unit, but it was a while ago, where we looked at, I remember there were questions where we looked at what's another way, like what are some ways of writing this number using powers, right? So this one would be 16 and 1. This is where it gets a little bit tricky, and probably both for grade 7s and for grade 8s. You have to consider that if this one worked for positive numbers, could it also work for negative numbers? And in fact, negative 2 times negative 2 times negative 2 times negative 2 also gives you 16. That is negative 2 to the 4. So that is a little tricky one that I don't think too many of you would have thought about. Likewise, that will work for that as well. Negative 4 times negative 4, or negative 4 squared. So those two are probably ones that people did not think about. Then it says to add up all of the x's. When you add up all of the x's, when you add 2 plus 4 plus 16 plus negative 2 plus negative 4, you're going to get 16. And when you add up all the y's, 4, 2, 1, 4, 2, you're going to get 13. Those are the x's, those are the y's. The difference between them is 3. So that was maybe a little bit of a tricky one. Most of you know the math for that one. It's just whether you would have come up with that thinking process. If you did, excellent job. So this one sort of looks at some spatial thinking and having the ability to fold this up. In grade 8s, we're just starting a project right now where you're having to think about nets and how things might fold up. What you're going to realize is that the 4 and the 6 will fold up and they will be opposites, which means if they're opposites, so if you picture like a Kleenex box, the bottom and the top, they're never ever going to meet at a common vertex. They will never ever meet. Likewise, the 3 and the 1 they are also going to be opposites. They will never meet, and likewise the 2 and the 5 will never meet. So that means if we look at those pairs, the 1 and the 3, the 2 and the 5, and the 4 and the 6, because it asks for the greatest product of the numbers on three faces that will meet, we want to be choosing the three biggest numbers, okay, of each pair, because these will never meet, but these could meet, etc. So that means 3 times 5 times 6, 90 will be the greatest product of the numbers that will meet. The ones that I've circled here in the different colors, they will never meet. So if we pick the highest out of those, each of those pairs, we will find the biggest product at a vertex. And I know that might be a little confusing, but just give it some thought. You'll kind of realize, I might suggest that you grab like, you know, a cereal box or Kleenex box and really look at, like, put the numbers on it and try this out, because you'll see, probably if you have it in front of you, you're going to see how it works. So I think most of you were able to maybe think this one through using your knowledge of geometry. The words here are very confusing, but essentially what it's telling you is that this triangle PQR is isosceles. And then this triangle BRQ is also isosceles. That's what it tells you in all this blurb here. And then they tell you that this one is 24. So knowing what you know about geometry, if that's 24, so is that. And you know the triangles add up to 180. So to find this angle, which is angle BRQ, you just do 180 minus 48. And that will give you 132. That'll be the angle BRQ. Now, if we look at that, that's right here. You know that these are supplementary angles. So if BRQ is 132, that means QRP right here will be 132. Sorry, scratch that. That will be 48 because it's supplementary. Brain freeze. So if this one is 132, this will be 180 minus 32. So this one will be 48. Because it's isosceles, again, this one is 48. And then again, you do 180 minus 48 plus 48, so 180 minus 96, I think. You'll get 84. Now, that will give you this one. So now what I'm going to do is actually kind of erase this here, and we're going to make a little bit more, sense. So I'm going to fill in, that was 132, because it asks you for QAC, which is this one here. So now what you have to do is picture this triangle right there. And you know that this one, so if this is the triangle, you know that this one is 24. And we just found that this one was 84. So to get this one, you just do 180 minus 84 plus 24. That's 108. 180 minus 108 will be 72. And that will give you, whoops, that's not a P, that one's A. That will give you the angle QAC. That's right there. The angle from Q to A to C will be 72. Again, I think it just looks confusing. Pretty much all of you have the knowledge and the ability to be able to got this question. I think if you didn't get it, you were probably just hung up a bit in all the words and what it meant and the fact that there were 3 different triangles going around. But really, if you broke it down into looking at the first triangle, second triangle, third triangle, it's actually quite a straightforward question. So for this question, you really just had to look at all of the different possibilities. So you had to just kind of think about all of the ways that the Cricut could do this. So one way that the Cricut could go up a 7-step staircase is to go one step at a time. One step, one step, one step, one step. So that's going to be one way. What if he goes 2 steps at a time? So, oh, sorry, I don't mean let me go backwards for a second. What I'm doing is I'm breaking it down into what if the staircase was only 1 step tall? I'm breaking it down into kind of a simpler problem. If the staircase was only 1 step tall, there's only one way of doing that. What if the staircase was 2 steps tall? There would be 2 ways of doing it, a 1 and a 1, or 2 steps at a time. So there's 1 way there, and there's 2 ways there. What if the staircase, instead of being 7 tall, was 3 steps tall? Oops, 3 steps tall. So you could do it a 1, and a 1. You could do it a 1 and a 2, or you could do it a 2 and a 1. So there are 3 ways in total. Now, what if the staircase was 4 steps tall? The interesting thing with a staircase being 4 steps tall is once you take 1 step, you have 3 remaining. So that's sort of one way to know. So once you have 1 step, then you can go 3 steps remaining, in which case there are 3 ways of doing that based on this one here. So you can go 1 step, and then you have 3 remaining. But you already know, based on your work here, that there are 3 ways to do that. So there's really 3 ways of doing that case. But what's another way of doing 4 steps? Well, you could do 2 steps first, in which case you would have 2 remaining. But based on our work that we just did here, we know that there's 2 ways of doing 2 steps. And I may have lost you, I'm not sure, but you know there are 5 ways in total. If I've lost you, the other way of doing the question is to literally just list all of the possible ways of doing it. 1 step, 1 step, 1 step, etc. And then 1 step, 1 step, 1 step, 1 step, your last one being 2. And then 1 step, 1 step, 1 step, 2, 1 step, 1 step. And keep going through like that, but doing it in a systematic way that you don't miss any. This way, if you understand it, is a little bit easier to not miss some. So let's go through 5 steps. And we're going to do 5 steps in the same way. So if I go 5 steps, if that's how big the staircase was, I could first take 1 step, and then there are 4 remaining. But based on my work right here, I know there are 5 ways of doing that. My alternate way, though, is to do 2 steps with 3 remaining. But based on what I did up here, I know there are 3 ways of doing that. So that means in total there's 5 plus 3, or 8 ways, if the staircase had 5 steps. So we're going to continue that. So let's see what happens if the staircase is 6 steps tall. I could take 1 step first, and then I would have 5 remaining. But I just found out that there were 8 ways of doing 5. But alternatively, I could take 2 steps first and have 4 remaining. And I found out that there are 5 ways of doing 4. So that means together I've got 13 ways. So now finally, even though it seems like it took me a while to get here, I was following kind of, again, like a systematic process. Now I'm at what the question was actually asking me. What if the staircase was 7 steps tall? I could first take 1 step and have 6 remaining. But based on the work that I just did, I know that there are 13 ways of doing that. Alternatively, I could first take 2 steps and have 5 remaining. But based on what I did up here with 5, I know there are 8 ways of doing that. So I know there are 21 ways of doing 7 steps. So again, what I did was I simplified the problem. I said, if there was only 1 step, there is only 1 way. If there were 2 steps, here are my 2 ways. If there were 3 steps, here are my 3 ways. Then I can actually use the work that I did here to simplify all the rest, because 4 steps really just becomes 1 and 3 or 2 and 2. And then 5 steps becomes 1 and 4 or 2 and 3. And I can use the work from the previous one to get my answer, which is 21. The other way, as I said, of doing it is just to list all of the possibilities. The problem with that one is you are more likely to forget 1 or 2, because a lot of you got like an answer of 20 and something like that. So you were so close, like you put 20 and the answer was 21. So that's the only problem with listing them all, is sometimes you're likely to forget one. Again, this was a really hard contest. Remember, the whole point of joining these is to learn something new and try to get better in terms of your problem solving, and hopefully you have done that.